Good evening, ladies and gentlemen, and welcome back to Advisors Webinars. Now we are in, hopefully, pandemic recovery series. It has been quite some time since we offered something, but now we're back with something extremely important and very interesting: big data. What is big data? Why do we need big data? What are the applications of big data? Can we live without big data? Many interesting questions we are going to ask tonight to our two interesting guests.
Hi, Dr. Saadi.
Good evening. How are you?
I'm doing very well. Thanks so much for having me today. I'm very much looking forward to this session, and I'm very happy to share some of the insights that we have regarding big data. So thank you so much for inviting me. I really look forward to this particular webinar.
Thank you. We're most welcome, and thank you very much for staying up so late, because our friend Jan-Willem Middleburg is joining us from Singapore, and it is around 1 p.m. at night.
Correct.
Okay.
Yeah, but no worries. I'm still full of coffee and full of energy. So we're going to make it a very interesting session.
Okay, hopefully. Thank you very much. And we also have Dr. Ibrahim Kebbe. Can you turn on your cam? Okay.
That's me. Can you hear me? Okay. Can you hear me now?
Yes. Good evening, Dr. Kebbe.
Good evening to you too.
Okay. Now, first of all, I'm very happy to be back again with our esteemed participants. Tonight, we are going to speak about big data. Next month, in September 24 and 25, we are going to participate in a PMO summit with our partner in Turkey. And tonight we'd like to introduce the Big Data Framework Organization, which has the Enterprise Big Data Framework established by President of the network, Jan-Willem Middleburg. Good evening, John. You are muted, it seems.
Good, I think you're correct. Thank you so much, Dr. Saadi. I'm very happy to be here today and to showcase all of the participants a little bit more around the Enterprise Big Data Framework. And I'm going to talk a little bit about why this was created, what are some of the main concepts, and I will also explain towards all the participants a little bit more about how they can use this in practice.
Excellent, excellent. We are very happy that first, we are partners together, part of Advisors ecosystem, for providing these interesting solutions to our partners and clients and participants and friends in the whole MENA and Africa region. Second, I'd like also to welcome Dr. Ibrahim Kebbe, my dear old friend back from university. I think your cam is off. Can you turn your cam on, please? And Dr. Kebbe has been accredited by APMG as Enterprise Big Data Professional Trainer. So we have two speakers tonight. We're gonna start with John, then afterwards Dr. Kebbe, and finally we are going to take some questions and answers. And I have a couple of questions that I would like to ask you after we finish. So if you like, we're gonna start now with Jan-Willem. The floor is yours. You can control the screen from below, from the next.
Yes, absolutely. Thank you so much for the very kind introduction, Dr. Saadi. And once again, thank you so much for inviting me today. I'm very happy with the established partnership. And I hope that today I can showcase all of the participants in the webinar a little bit more around big data. As you will know, the concept of big data is very significant. It's also very large. So I can probably talk about this for 5-6 hours straight, but I will promise to keep it concise. And I will also promise to make sure that we start to highlight some of the main key points. So before we get started, let me take a very brief moment to introduce myself. My name is Jan-Willem Middleburg, and originally I'm Dutch, so I'm coming from the Netherlands. Currently, I'm in Southeast Asia, and that's also where I'm presenting from today. I'm also the president of the Enterprise Big Data Framework Association, which is providing the Enterprise Big Data Framework. What we've tried to do is establish an independent body of knowledge for the development and advancement of big data practices. And what that means is that we are there to make sure that we inspire people and that we help them to learn more about how you can use big data in order to make better decisions. Because it's my very strong belief that if everyone in any organization would start making better decisions every single day, which are based upon data and based upon facts, we can all make sure that we get towards a better world. So in order to do that, we have developed a framework. Because when I started my career in data science and data analysis, I was really struggling to find, well, what is a best approach? How can I get started? There were all these different programming languages that I heard about and all different kinds of tools, but there was not a uniform framework available that could be used by every type of organization. So based over our experience from the past decade, this is how we developed the framework. And today I'm going to explain a little bit more about what the framework is and how any organization, no matter whether you're small or large or very capable or not, can get started with using big data best practices. So one of the key things I want to state right from the beginning is that the big data framework is a vendor neutral program and framework. And what that means is that it doesn't really matter which technology you're having. It doesn't really matter what type of organization you are. You can use this vendor independent approach to learn more about how you can improve data-driven decision making. So that's what I'm going to talk about mainly for today. Good, so what I've done for today's session is that I have selected a number of key topics to kind of highlight why you should learn more around big data. So why this is such a significant topic in any enterprise organization. But I'm also going to explain to you how you can get started. So what we will be covering is the question of why, because that's the title of this presentation. But we're also going to look specifically at what you can do. So I'm going to help you understand what any organization can do in order to get started. And how I always explain how to get started, it is building capability, making sure that you become better every single day at increasing those capabilities that you would need in order to increase your data-driven decision-making. So the way that that capability building is done is going to be through the big data framework, and that's what I'm going to explain a little bit more around. So obviously, these are all concepts that will be explained in more detail if you ever take a certification course with Dr. Saadi, and advisors will, at the end of the session, provide you with more information on how you can sign up for that. Good, I've divided my presentation into a number of segments, and I'm going to get started very briefly with putting big data into its context. Because there's a lot of misunderstanding around what big data is. A lot of people think it's very technical, it's very difficult, and it is something that is very challenging to implement in organizations. And what I want you to get started with today is the realization that big data and all its variety of different explanations is really significantly changing the world. Almost all of the successful companies that have risen in the last decade are data-driven. Think about big technology companies that are facilitating our lives through our smartphones today, or think about social media companies that are facilitating most of the communication. The one thing that all of these successful companies have in common is that they're making data-driven decisions. And as a result, you see that the interest in big data, the people that are searching for big data, has been increasing ever since. So you see now that universities have started to set up data science programs. You see that there's a variety of different programming courses now available. And there's a variety of different aspects like machine learning, data science, which is growing very, very rapidly. The thing that all of these things have in common is that there's this increasing demand for people who have knowledge around data analysis and big data best practices. And that's what is driving the growth behind that. And that's something very important to realize, because every company nowadays that is making data-driven decisions in the long run will outperform a company who doesn't. So if you have two competing companies and one is making these data-driven decisions and the other is just still taking decisions based upon, let's say, their experience or the things that they knew from previous things, I will guarantee that the company that is taking these data-driven decisions in the long run will win. Maybe not in a day, maybe not in a week, but if you take that approach consistently over a number of years, the company that is making data-driven decisions will win. So that means that it becomes very crucial and very fundamental to start learning about this yourself. Because if you understand how you can leverage and understand the data in your company, you can start to make sure that you have a very successful company in the long run. And I think that is something that almost every company wants nowadays. So that, of course, sounds all very nice. So why do we then need a framework? Why are we today presenting the Enterprise Big Data Framework? Well, in order to start working with big data, you need to get some skills. And what we refer to that in the Big Data Framework is that you need capability. So a lot of companies say that they're interested, they know that they would like to get started, but they are lacking the knowledge and skills. And typically how most organizations get started is that they approach a particular vendor, typically a technology vendor, and they will provide them with a software product. And that is how they feel that they have a big data organization. That's not the case. In order to truly get value from your data, you need a more rigorous and step-by-step approach. And what a lot of the technology vendors forget is that big data is a people's aspect. You need people with the skills, the motivation, the knowledge that can actually retrieve value from data. So what we've done with the Big Data Framework is that we're providing this hands-on and very practical approach towards all of the key components that you would need to think about in establishing your big data organization. I'm going to explain that a little bit more in detail. The great news that I want you to note right from the start is that the Big Data Framework is completely free of charge. So it means that every organization across the world is able to download the materials and use the framework as they see fit. It is licensed under what is known as a Creative Commons license, which is the logo that you see on this next slide. And that means that you can build upon this, you can publish articles, you can publish materials from the Big Data Framework, as long as you provide the right attributes and references. So this is why the Big Data Framework has grown so significantly, especially in the last 3 to 4 years. Many large organizations across the world that I had the pleasure to either provide presentations to, like today, have already started on this journey of embedding the practices of the Big Data Framework. We have a number of very famous case studies with some of the biggest telcos and insurance companies across the world that are educating their people according to the Big Data Framework and that are implementing their solutions based on the structure that I will showcase in the next few minutes. So I highly encourage you to get started with that as well. So what we're aiming to do with the Big Data Framework is basically to target 3 main audiences. First of all, we want to help out everyone that is interested in big data and is unable or not knowledgeable on where to start. I still remember my frustration from many years ago that I wanted to get started, but I couldn't find any suitable approach that could help me. The second target audience is larger organizations that are having tremendously large data sets and that would like to understand how they can retrieve value from that on a day-to-day basis. And the last one is the education sector. So with the free guides, the materials, the knowledge that we're developing and providing, we're hoping to inspire a younger generation to see that this is a really important topic and that they should learn more about that. So I hope that after today's session, I've also inspired some of you to get started and to learn more about this. So how do we do that? So what we've done when we started to develop the framework is that we looked at what are some of the most common job roles and skills that you would need in order to become a data scientist or a data analyst, or for instance, a data engineer. So we really took a role-based approach and looked at what are some of the key skills and requirements that are necessary and at which particular levels. And that has resulted in this certification scheme that Dr. Saadi just mentioned, and with which APMG is a partner in itself. So this provides a little bit of the context. It gives you a bit of an information of why this framework was developed, what the requirements were from the market in order to do this, and especially why I'm so interested in explaining about this, because there's this very significant need, and people who understand that will tend to be in businesses who do better than other businesses. So the next few minutes, I'm going to give you a high-level overview of the big data framework itself. Again, this is a larger topic. Well, I'll try to condense it in just a few minutes. The next slide is really important because this slide will give you an overview of the 6 main capabilities of the enterprise big data framework. This is the main model and includes all of the 6 capabilities in which any organization would need to start building their knowledge and skills. I'll briefly explain the model, and then we will dive into each of these 6 capabilities in a little bit more detail. At the heart of the framework, you see the words big data strategy. And this is for any company where it all starts. Without a big data strategy, it's going to be impossible to be successful within big data. There is so much data out there in the world that you can potentially spend the rest of your life looking at interesting analysis and analyzing all kinds of data. You will not live to see the day to analyze all the data. So what you would need right from the start is a very clear overview of where are we going to retrieve value. What is going to be the return of our investment? And given our organizational context, which decisions can we make in order to make sure that we can get that competitive advantage? That's what big data strategy is all about. The second main module covers architecture, because in order to analyze large quantities of data, yes, you will need to know a little bit about IT. You will need to have databases that are able to store massive quantities of data. And you will need to have solutions that are able to process these large quantities of data without waiting for the results for days. So in order to process very large quantities of data, you would need an IT architecture that is able to support that. Very closely related to that, and that brings me towards the third domain, is the domain of algorithms. Anyone who wants to retrieve value from a data set will need to know how to extract that value. The topic of algorithms is also sometimes referred to as data science. It is the knowledge on how do we retrieve the value from a large data set. So if you've ever heard colleagues talk about things like machine learning algorithms, or for instance, predictive analytics, that's the domain of algorithms. So in your organization, you would need to have people that know, given a particular data set, how they are able to extract the value. And that requires knowledge and skills. I always say that without the knowledge and skills to retrieve the value, a data set is just a data set. And it will be worthless to anyone who's unable to retrieve the value from it. Then we're going to move to some of the key components, which are going to be tremendously important, especially for larger organizations. And the next one is processes. Larger organizations need to take a lot of different aspects into account when they're analyzing their big data. Think about data privacy regulations, which are increasing everywhere across the world. But also think about data security or data management or data governance. For all of these aspects, there are processes that organizations need to have in place. And they might, for instance, be audited on a yearly basis to showcase how they are dealing with their data about customers. These processes are very fundamental, and you need to set them up right from the start and build capability in this domain as well. Then we're going to move to topic number 5, which is typically my favorite topic, because big data functions is all about the people. In order to be successful with big data, you would need to make sure that you have a team that is able to do that. You need to invest in people who have the skills to analyze data. But you also need to look at how do you structure your organization. All of these topics are covered in the big data functions capability. And the key goal here is to grow your capability over a period of time. The last major domain is that of artificial intelligence. And I very frequently receive the question, what is the difference between big data and artificial intelligence? The answer is actually quite simple. With artificial intelligence, we're trying to imitate or mimic the decisions that we as people make. But in order to do that, you would need to have data. Think about, for instance, a self-driving car that would need to make decisions whether to go through traffic lights or, for instance, to hit the brakes. What that self-driving car will need to do is within seconds go through an entire database of traffic rules and make the right decision. So artificial intelligence basically builds upon the structure that you would need within big data. A lot of companies are seeing now that the topics of big data and artificial intelligence are very strongly interwoven. And if you look at it technically, you would need the same strategy, the same architecture, the same processes as we see here in the framework. It's just that you need a different class of algorithms. I don't go too much into the technical details of this difference today, but I hope that you see that this ring is around the big data framework for a particular reason. So if you have all of those other 5 aspects well in place at a high level of capability, it means that the step towards artificial intelligence is not going to be that large. Good, so that's a very high level overview of what the enterprise big data framework is. And one of the key things that I want you to take away from that is that it consists of these 6 major capabilities. All of this is further explained in the certification guide, which you see here all the way at the right. And in the Enterprise Big Data Professional course, which is taught by Dr. Saadi and advisors, you can learn more about these 6 capabilities in detail. Let me go through these in a very, very high level overview to show you some of the things that you would need to learn in order to build each of those 6 capabilities. On this next slide, you see how you can start to formulate a big data strategy. And as I mentioned previously, there's so much data out there that it becomes impossible to analyze all. And one of the very famous quotes I always like to use, which you see on the left-hand side, is that if you don't know where you're going, any road will take you there. And that is especially true for big data. Organizations that start with big data and they don't have a clear plan, they can run all kinds of analysis, but they will never reach the end result or get the competitive advantage. This is, by the way, a quote from the book Disney in Wonderland. So in big data strategy, you're going to learn how to formulate a big data strategy, which is basically the blueprint for the rest of the steps that you're going to take. Next, we're going to look at big data architecture, because you do need to set up some technology in order to do that. On the next slide, you see the reference architecture that is discussed as part of the big data framework. So you will need to look at what are the different components that we would need to set up and which particular tools do we need in order to analyze the data. By taking a structured and vendor-independent approach, you can make sure that you choose an IT architecture which is suitable for your own organization. Because if you look at architecture, you can see that there are hundreds, if not thousands, of different tools that you can use. So making smart decisions on which databases you're going to use, which processing engines, which big data analysis tools, or which visualization tools is going to be very crucial towards your success. So the big data architecture section will cover these technologies and some of the underlying key concepts into a lot of detail. The third major aspect that I mentioned already is algorithms. So just to give you a very quick example, on the next slide, you see a clustering algorithm. So think for a moment that this would be a group of customers. And these are the customers that you have in your database. What you could do with clustering algorithms is to separate these customers into, for instance, 3 different groups. And that's what the slide that you see on the right. What you could subsequently do is that, for instance, you could send them different marketing materials, or you could show them different advertisements, meaning that you could tailor your offering towards the different customers in your database. This is the technique that is employed by almost every large company. They're segmenting their customers and providing a different offering because they know that they will be able to be more successful if they're tailoring their offering towards specific customers. So in this section, you will learn more about which different techniques exist. I'm just giving you a very simple example right here, but there are dozens of different algorithms that you can choose and learn from. Next, you need to have a fundamental understanding of processes. Processes are going to be crucial for every large organization. So in the big data framework, we're going to look at a variety of different processes, like, for instance, data governance, data management, and the data analysis and analytics process, which you see here on the slide. The key purpose of these processes is to make sure that a large organization is in control of their data and that they know exactly at every given moment what is happening at the different aspects in their organization. Having a sound processes in place, especially for larger companies, is going to be crucial to success. In capability number 5, we're going to look a little bit more at the people aspect. But before I go there, I'm going to give you a very high-level example of, for instance, the data analysis process. So if you are analyzing data in a large organization, you would like to keep a consistent approach. And on the slide in front of you, you see how we're moving from business objectives towards ingestion, preparation, and analysis, which together is known as the data pipeline, towards actual results and business decisions that people can take. So this is an example of one of the processes that is being covered within the capability of big data processes. The next major topic is the big data functions. And this is typically my favorite topic because this is all about people. In order to move an organization towards data-driven decision-making, there is more required than just fancy technology and, for instance, nice tools. You need to change the people. You need to make them understand how data-driven decision-making works and that they support results that are coming out of the analysis. And that is much easier said than done. So one of the key ways in which you can address that is by establishing what is known as a big data center of excellence. And on the slide in front of you, you see some of the core components of a big data center of excellence. So starting with big data in any organization requires centralization of knowledge, building proof of concepts, the agile methodology of working so that you can very quickly produce results. So these are some of the key people aspects that we're looking for in the big data functions capability. And then last but not least, almost the topic that everyone is talking about is artificial intelligence. So in order to understand artificial intelligence in further detail, you should know that it is actually a combination of a number of different knowledge domains, which is what you see at the right of this slide. Artificial intelligence, in essence, consists of the domains of machine learning, natural language processing, knowledge representation, and automated reasoning. And it's a combination of these 4 that can teach a computer to make very similar decisions as a person could be. The beautiful thing about artificial intelligence is that it will work on exactly the same data sets that we're processing within big data. So this brings a number of different benefits, because if you have set up a big data organization, making the step towards artificial intelligence is not going to be that large. You just need some different capabilities and some slightly different setup, but you could leverage the same data sets that you're already analyzing. So my key message here is that if you want to start working with AI, start with big data first, because big data is going to give you the solid foundation that you would need before you can start with artificial intelligence. And in the last key capability, we're going to look at things like machine learning, natural language processing, and automated reasoning, and how you could apply them on top of your big data structure. This is again the reason why this is depicted as a ring around the framework. Good, so what I've tried to do in this first 25-30 minutes is to give you an overview of the big data framework. So once more, I'd like you to pause here for a moment and to review back what the 6 capabilities are. And the reason that I'm calling these 6 capabilities is that you can become more skilled and more capable every single day in each of these different areas. I'm pretty sure that Dr. Saadi is going to tell you more around that towards the end of this session. But just as some final remarks, how can you get started? The first key piece of advice that I'm going to give you is start learning more. What we've done with the Enterprise Big Data Framework is that based on the capabilities that I've just explained, is that we've composed a certification program together with APMG International. And I'm very pleased to state that Advisors is the accredited partner for us in the region. So it's a consecutive number of programs. You will need to start with the Big Data Professional Program to learn more and get some of the fundamental concepts. But it's not just that program, it's actually an entire journey. In case you want to learn more beyond just the overview, there are approaches to learn how to become a big data analyst, or even one step further, a big data scientist. This will require quite a bit of studying, getting familiar with the concepts, but it's also an international accreditation that you can strive for. And what we've really tried to do with APMG International is to set the global standard of what does it mean to be a certified big data analyst. The entry-level course, which is the professional level, is relatively straightforward and will be accessible for anyone without any prior knowledge. But the more advanced levels, like the analyst and the scientist, do require you to really spend some time analyzing data, solving problems, and learning how you can get value from massive data sets. Good. I'm going to hand it back to Dr. Saadi right now. I hope that this overview provided a good summary of what you can expect from a big data framework, why we've created it, and most importantly, that you learned something new in the last 30 minutes.
Jan-Willem, thank you very much. You're very interesting. I already have 3 questions of my own, but I'm gonna leave till the end.
That's perfect.
So thank you very much. Let's start directly with Dr. Kebbe.
Hello and welcome. My name is Ibrahim Kebbe, and I will be talking about big data from the perspective of what and how. So without further ado, okay, so this is me. I am a PhD in Systems and Information Engineering from Hokkaido University in Japan. And before that, I was a mechanical engineer. And my entry to big data was from a classical background, the background of analytical or inferential statistics and operational research. So this is just a brief, resume about me. And for 25 years, I have accumulated some fair expertise in academic development and corporate training. in different, in different industries. And until now, I'm still instructing at several universities, plus the training gigs that I get every now and then. And recently, I've been very interested in big data analytics because they simply expand the background I have had over the years. And as my colleague Jan-Willem pointed, the concept of big data analytics is a fundamental concept because of the material with which we work. So if we proceed with that, okay. How do you proceed with that? Okay, next. So what is big data? First of all, let us start with the cloth of our work, the big data itself. Anybody who has been around inferential statistics, they have realized that the sets of data that we used to use are small data, in the sense of they do not of not having the caveats or the complexities of big data. We used to have small samples out of fairly large populations, and then these samples were well behaved, and I stress well behaved here, because when it comes to big data, these insights that were promised by my colleague were actually coming at a price. The price being these four caveats, the four V's. You have the volume, the sheer volume of big data, which is produced on a daily basis. You have the velocity at which these volumes are produced day after day, because if we come to think about them, this is actually justified by the sources being social media and related devices, sensors, including any sensor that works within IoT, Internet of Things, and websites and their related databases. So in this case, we talk about an infrastructure which is needed in order to hold this these large volumes and these big velocities. So we talk about a distributed infrastructure, whether we are talking about storage or processing. Both of them need to be distributed because we are talking about very large volumes. This is on one hand. On the other hand, you have the variety and the veracity of big data. Variety being the different formats by which big data comes. You have audio, video, text, and so on. None of which are actually well behaved. On the other hand, you have the veracity, whether or not we have a full or a tabular, a structured data. So in what comes next, I'm going to talk a bit about these matters. So first of all, to talk about the formats. As I said before, you have the structured data, the well-behaved structured data. In this case, we are talking about non-requisite, multi-sourced formats, and of course, they contain missing values. And this is the thing here about veracity. Veracity means whether or not your data is actually true or error-free, if you want. So in this case, we talk about the veracity related to missing values on one hand. On the other hand, you have erroneous entries. For example, you have a database that has been started out 20 years ago, and then somebody realizes that there are some variables missing. I mean, this database is accumulating records over the years, but again, there are certain variables that needed to be added later on or recalculated, and this is also a big problem. Not to mention the fact that sometimes some of these values are missed. So we talk about missing values, or so you have missing values, you have miscalculated values, you have new values added, and so on. That actually is not very structured. So it is not very well behaved. So a system that works with big data is actually required to clean and structure these data in order to be able to ready it for analysis. So we talk about something that takes this is part of big data infrastructure, by the way, and it actually takes lots of work. That's about 80% of the job. So the processes that are related here in making these data behave well is sourcing, catching the data from different sources, cleaning them, and wrangling them. Wrangling them, that is to say, putting them in the final tabular form that is going to be used for extracting the values. So you have those different types of formats that we have here, XML, sensor data, and so on, and even metadata related to the files. Next, we have here the drawing the insights. So what we have now is data that has been cleaned. So it is a well-behaving big data. And then we ready ourselves to start the analysis. So this analysis goes by 3 steps. The first step is to explore. So we talk about EDA, the exploratory data analysis. In this case, we're talking about displaying the data, checking the structure of the big data file that we are looking at. Of course, we cannot actually look at it in details the way you used to do for small data. But however, what we do is we look at it from different perspectives in order to check it out. Then we explore it simply by visualization or otherwise. After that, we appropriate what kind of analytics we want to do. This is the second step. We appropriate the analysis that we want to affect, and we affect it. And of course, this is following the business problem and the strategy that is being used. What do we want? We want, for example, to find a relationship. So maybe we use correlation, or we want to find the trend of that relationship, in which case that we use regression, for example, and so on. Finally, once the insight has been drawn, it has to be put in a way ready for ingestion with respect to the decision maker. That is to say, we just visualize the final insights of that data. So in this case, we start out with the business objective, we define the business problem, then we ingest the data the way I was talking about, the collection and sourcing of data, then the preparation of data, the cleaning, wrangling, and so on, then making the analysis the way I showed you, and then finally represent the data, visualizing it and communicating to the different stakeholders. Now, in big data analysis, again, continuing with drawing insights, we have to realize that we rely heavily, as my colleague said, we rely heavily on machine learning, especially that this is the first step into AI. So in machine learning, we talk about 2 main categories of problems. You have supervised and unsupervised. In supervised learning, it means that we use a data set, a certain data set that we have cleaned, in order to draw some aspects or some trends of the data. We find some patterns within the data and then use these patterns in order to make, for example, to make predictions, to make interpolations, extrapolations, and so on. So an example of that would be, for example, classification or regression, because in regression analysis, as you know, we use the data set, and then we drop it once we have a trend, and of course, an estimate of the error of that trend. Once we have that, we don't need the data set anymore. We just build our insights on new data. We build new data with our insights. This is on one hand. On the other hand, when you have unsupervised learning, it is the opposite. There is no training set. The training set, or the set of data that we have, is always reused and reused. An example of that would be clustering or correlation. For example, in clustering, we try to isolate certain characteristics or biometrics of a certain audience against, for example, their behaviors or their attitudes. So once we relate these 2 together, the more we grow this data set, the more insight we are going to get. So it means that we use and reuse that data over and over again. So then we talk about the classification of the analysis techniques, because when my colleague talked about the different roles of big data, these roles are actually divided into 3 main categories. You have the category of strategy, then you have 2 categories, one of them related to infrastructure, which is the engineer and the architect, and then you have the analysis, which resides upon the shoulders of the analyst and the data scientist, so analyst and scientist. Now, what you see here in this slide are 6 categories of analytical problems or analytical methods that we use that we apply on big data. You have the descriptive analytics, which means that we just look at the descriptive statistics that we have on any data set, like the central tendencies, mean, or average, or the 3M, mean, mode, and median. Or we look at the dispersion, the quartiles, for example, how the quartiles are dispersed, the standard deviations, the variances, and so on. So in this case, we are talking about visualizing summaries of the data, which is descriptive statistics. Then we have exploratory, which is an additional step. In this case, what we do is we check out how the data is dispersed. That's to say, pattern that the data, the whole data, actually draws. That would actually help us explore the nature of that data. And then we have the inferential analytics, in which case we have a hypothesis that we need to prove. This is hypothesis testing that is drawn from inferential statistics. So we try to prove or disprove a certain hypothesis. So we start out with the status quo and then try to challenge that status quo into something different. For example, let's say that you have a new electrical car that is going out there. So we talk about the mileage of that car, how much mileage it has. So the champion of these cars, for example, a different brand, an older brand, is boasting a certain, let's say, 160 miles per charge. So, and you are the contender. So your car is actually putting in something new. So in this case, you would be looking at trying to prove or disprove that your car is better than the old ones. So here, this is your hypothesis. The hypothesis starts out, the null hypothesis, that the champion is the champion and that there is no way we are going to replace it. Then we go a further step into predictive analytics, in which case we use a data set in order to drive a certain insight into the future. For example, looking at demand, the demand for certain products. We look at the trends for certain prices to go up or down and something like that. Then you have the causal analytics. In causal analytics here, we're not talking about correlation, just correlation, and we're talking about causality, that X causes Y, that X influences Y in a certain way. So in this case, this is a further step. And then the final step is to have the mechanistic approach, which bears on self-built functions. In this case, maybe we talk about optimizing something. It's like, for example, we have a good, service or product with certain specifications. How can we drive it? How can we, for example, achieve maximum sales, maximum profit, minimal losses, and so on, or minimal environmental impact, if you will, if we start using these causal relationships and predictive parameters that we've had from the last two types of problems. So in this case, this is just like a flow chart that tells you how to navigate these 6 problems. So if it is just that you need to report something, you just go for descriptive analytics. Otherwise, if you want to look for relationships between, irrespective of what the relationship is, you are trying to look at certain influence between 2 variables, an independent and a dependent variable, then you'll go to exploratory business objective. Then in this case, if you are trying to determine how one variable, which is the independent variable, influences a dependent variable, then in this case, you ask yourself one of 2 questions. If yes, if this is the case, you're trying to find the influence, well, is the effect you are looking for causal or not causal? If it is causal, then you will go for the causal business objective. Otherwise, you go to the mechanistic objective. Otherwise, if you are trying to predict something, okay, then in this case, you will go for predictive. Otherwise, you will go for inferential, the hypothesis testing problem that I was talking about shortly. Now, this is something that has been shown before by my colleague, but this is just a reminder here. That the infrastructure that we use and the algorithms that we use are either proprietary or open source, because here we are talking about the how. So the combination of these 2, the algorithms and the infrastructure related to IT, well, you have the freedom of choosing as a corporate or as a person, whether you want it to be a proprietary system, or you want it to be an open source system. By proprietary, I mean you just, for example, find a solution, you buy it, like from IBM, for example, and then despite the fact that we've insisted that this is something which is vendor-free, but if you have a vendor in mind, then by all means, it's your call. So it is either proprietary, you appropriate something, you buy a finished system, and then you work for it, some solution, for example. Otherwise, you go open source. And if you don't, like for example, going to the cloud for storage on one hand and sourcing, on the other hand, for the functional processing, like for example, using RStudio, for example, for the analysis. It's cheap, it's free actually, unless your system becomes, your ecosystem becomes too big, and it's open source. If you don't trust it, then you can go for your own cloud. You can have your private cloud to work within. So it's open options everywhere. Then the roles that we talked about before, as I said, as my colleague said, there are 5 roles. He talked about the professional, the enterprise big data professional, the analyst, and the scientist. Then you have the engineer and the architect. To show the the relationship between them, you imagine 3 categories of roles. You have the strategic role, the professional, and then you have 2 roles, one for the analysis and one for the infrastructure. On the infrastructure side, you have the engineer and the architect. The difference between which is that the engineer is the guy who is actually cleaning the data and sourcing it properly, whereas the architect is the one who decides how that is going to be. So it's like the engineer is under the architect on one hand. On the other hand, the same goes for the analyst and the scientist. The analyst is using prepackaged models, like the models, the 6 models I've shown you before. These models are pre-packed. The one who is going to unwrap the package and work within on the quality of the solution, on the speed of the solution, on the methodology that is used, on the parametric study for that solution will be obviously the scientist, whereas the analyst is the one who applies properly scoped problems to properly scoped data. So within this, we are actually looking at skills. You have 6 main skill sets that have to be distributed, of course, in different proportions across these 5 roles. You have to have leadership skills, especially for the professional, the enterprise big data professional. You have the technical skills, properly residing with all the others. You have the analytical skills, especially for the analyst and the scientist. You have ethical hacking skills with the IT people, like the architect, especially the architect, and the engineer. Communication skills, this is required from everybody, especially the professional. And then you have the statistical skills. Everybody needs to have an idea about the statistical skills in order to appropriate problems, to designate strategy for problem solution. In this case, we are talking mainly about the scientist and the analyst. Now, the workflow process, as my colleague mentioned before, it is made, the initiative of big data in any corporation is made through what we call Big Data Center of Excellence. For anybody who knows his way or her way around project management, this is typically a PMO. This is like a project management office that is supposed to be able to, by the end of the day, preach the grace or preach the importance of big data analytics. So in order to work within that center of excellence, we start out with the team, as mentioned before, and then this team works within a certain lab in an environmental setting in which all these professionals can work together seamlessly. Then you have the proof of concept. In this case, we are talking about what we call use cases. In project management, we call that business case, the business case that sets the okay for a certain project. The same goes for the proof of concept, which resides in use cases for big data application. It has to be justified by the end of the day. Then you have the agile methodology, which is used in order to work within big data analytics. And then finally, you have the charging model. That's like a cost-centering work for every initiative in big data in order to draw its worth, in order to visualize its worth, in order to be able to propagate it into the future. Finally, the framework, as was mentioned before, is residing on 6 core capabilities that have been explained before. But the important thing here is that this framework is not supposed to be, or practically not supposed to be, applied in full from the first time. There are maturity gaps that need to be scaled one after the other. So what we do here is we go through a business development approach. We look at where the company is, where the organization is now with respect to big data analytics, and then we decide on the next step to go to the next level. So we take it one step after the other. First of all, there is absence of practical methods, and then you have the analytically impaired company. They are trying their best, but they are looking at the wrong data and the wrong processing of that data. And then you go to the localized analytics, where you have some departments that are actually working on analytics, whereas all the others are not. Then the third level, the analytical operation, for example, where you have operations working within analytics, but nothing on the level of strategy. Then you go for the analytical enterprise, which means that big data analytics have seeped into the strategy of that company. And then we have the data-driven enterprise, the likes of Google or Facebook, or those big names that we have out there. And this is all that I have to say about it. I hope I didn't take too much time, and thank you for not sleeping.
So you are taking a lot of caffeine tonight. Are you going to be able to sleep after that?
No worries at all.
Okay. So I'm gonna start myself with a couple of questions before I start to present some of the questions of our audience. Yeah. And my first question is to Jan-Willem. You are in your elevator, the 30-second pitch, and there is this leader, digitalization leader or CEO, whatever, and you wanted for the past 2 months to have the chance and speak to him about big data. What do you tell him?
What I will tell him is most specifically that in order to win in what is today the data economy, you need to start making data-driven decisions. Because if you don't, your competitors are going to overtake you. Not today, not tomorrow, but a year from now or 2 years from now. So that means that you will need to build crucial capabilities in order to analyze and process data. And the big data framework will exactly help you with building these 6 core capabilities. So in other words, the big data framework will help you to win in the data economy. And I think that is what every business leader is looking for today.
So this means you are going to go back and to link to being competitive, being early to market, fast to market. You are going to speak about understanding your clients' mood and how they think and what is important for them. You are going to speak about optimizing the resources that you have and to do more for less in general, how to realize multiple benefits in your organization by providing a more realistic grip on what is going on, which we cannot.
Exactly. I think you're summarizing it very adequately, because big data is a business decision, and it's not just a new tool. It's not just a new approach or a new way of working. Big data is so tremendously interesting because it enables companies to get this competitive advantage by having information and decisions before your competitors can have that insight. And that's what's really a differentiator. And I truly believe it when I say that companies who are able to do that well will get that competitive advantage. And if you look at all the successful companies over the last decade, they're all data-driven. They're all making decisions based on the data that they're collecting about their consumers.
Okay, interesting. Now, I have my 3 questions. It's my veto before I go to my audience. And the second question goes to Dr. Kebbe. And where does the scientist start and versus AI? So what is AI versus a data scientist, or what is the relationship between these two? Because I'm asking this question out of real curiosity. Myself and Dr. Kebbe attended a session with our partner, the Gulf Downstream Association, and they hosted McKinsey people who have a very interesting solution for the downstream business to optimize things. And they were utilizing big data. And they were talking about AI. Then I asked them a question and they said, no, the algorithm is not discovered by the AI. It is developed by the data scientist. So what is the difference and the relationship? If we have a data scientist, do we still need to have AI or vice versa?
Well, this is a very deep question. AI is a driving force. It is something that evolves over time. Basically, it has gone through 3 revolutions. I have been a student of the 2nd revolution. Back at that time, we used to try to impose or put the human cognition into machines. Now, we are not trying to do that. We are trying to put this cognition mainly into problems and problem structure. That being said, the data scientist is the one who decides on the structure of these algorithms that work in AI. The handle to AI is machine learning. And then you have further deep learning. So in this case, we talk about how much you will automate out of these problem-solving problems. So let's say, for example, that you want to designate part of the wrangling to AI. So you let AI work on part of that wrangling. Like, for example, giving it this task, this particular task, to artificial neural networks. It has been done before, and successfully, I might add. But the thing is that how much are you willing to do so? Because this is something which is more or less expensive. It's like this. If you have a man and a horse racing together, the man is not riding the horse. The man is, running along with the horse. Who will win? What do you think?
The one who knows the right direction to win.
Okay, I get that. But the actual answer is depends. If the distance is like 10 meters, obviously man is going to win. It is easier to coordinate 2 legs rather than 4 for such a short distance. Beyond the 10 meters, the horse wins hands on. Hands off, that's it. So the problem is with AI like this. Are these problems that are being solved, do they give themselves easily to AI? And is it worth to put time and money into AI to solve this family of problems? If yes, then you go with AI. Otherwise, you stick with what we know. So that's to say, we stick with the analyst. The work of the scientist starts with exploiting new methods of actually working out AI techniques that are going to alleviate so many parts of the work. That's to say, the man is the analyst and the horse is the scientist.
Okay. Now I'm gonna have to take some notes from Jan-Willem on the answer of Dr. Kebbe, please.
Yes, well, I think I like the comparison between the horse and the man. Obviously, I think that's a very good analogy. The way that I look at the difference is they are both different knowledge domains, but there's a very strong overlap. And in order to do artificial intelligence, what I also tried to explain during my presentation, you need to have the same infrastructure, the same processes, the same databases that you will need in AI. So the main differentiator is that artificial intelligence is going to look at the mimicking of human decision-making. And that means that we also need to take into account things like emotions, the fact that people take different decisions based on previous experiences. So there's a high degree of personalization and individualization. So the level of complexity in AI and those core aspects are more difficult than just looking at a data set. And that's also why today we still haven't fully figured out artificial intelligence, because most of the systems and most of the vendors that are claiming that they have AI systems are not intelligent at all. If I ask a regular chatbot a difficult question, I don't get any good answer. So mimicking true intelligence and claiming that a system is truly intelligent, we are still a very long way to go there.
Yeah. Okay, very, very interesting. Thank you both. And my last question, before I start to take our dear participants' questions, is how can we benefit from big data in giga projects and capital infrastructure projects? This is a very essential question because the other day we had a discussion with some of our colleagues at Aramco, and as you all know, we collaborate with everybody to establish some conferences and talks. And we had this question: what is the role of big data in giga projects, if there is a role? And I'd like Jan-Willem, please, to
yeah, of course. Well, the analysis of data is used at a variety of different aspects. So obviously, one of the primary use cases that's always being used is specifically within the marketing domain. However, the techniques of big data are also applicable on logistics, on facilities, facility management. So let me give you a very short example. Suppose that you have large infrastructure projects, and you could predict which elements of an infrastructure project will need maintenance. Or you can start to see where it's most likely that any kind of problems will occur, so that there's any kind of construction risk. All of these aspects will use the exact same underlying algorithms that you would use in order to forecast a marketing campaign. It's just a different set of data. So the underlying techniques, and if you understand them, I think you can apply them to whatever domain you're working in, are going to be very similar also for construction. You mentioned Aramco with their giga projects. They will have massive data sets that are available. So it's just understanding how you can get the value from that data. So in other words, you need people who understand how these algorithms work. And then you can, regardless of which industry, you can achieve value. So that's my view on it.
Okay. So let's start to take some questions from our participants. And I have a question here from Dr. Osman Akman. Which one is the most crucial for companies, analysis or analytics? If you like, Dr. Kebbe, to answer that.
Well, analysis and analytics in the semantics of things. Analysis predates analytics, because analytics is, as a structure, as a linguistic structure, is the combination between analysis and statistics. So we have the first part of analysis and then the second part of statistics. So we have analytics. So in this case, it might seem that what we are trying to do is we are trying to implement statistics within analysis. But some people, what they say is that no, well, analysis is simply the old school, analysis that they used to apply without resorting to big data. So what I say is, whether you say analysis or analytics, it is potatoes and potatoes, right? What actually makes the the difference here is what kind of value you are trying to seek. Let me give you an example. One frustrating thing about statistics is that many statistical tests, they don't give you the direction of patterns, whether they are increasing or decreasing. They simply give you that there is a change. But when it comes to big data analytics, we have evolved techniques, if you will, that are giving us directions. And this is like a surgical tool that you use instead of using a regular knife. So maybe analysis is the knife, and then the surgical tool is analytics. Well, it depends on how you are handling it. That's the idea.
Okay, thank you. I have from Lakshmi Ram, interesting question. And this is for John. How is big data analysis, or how can it help small and medium-sized corporate hospitals in relation to clinical excellence and operational excellence for management?
Good. Well, that's a very, very interesting question. Basically, this is addressing how can healthcare be professionalized and be optimized through these techniques. So just let me kind of illustrate this by a couple of key examples. So look at a hospital. So when you're sick and you get into a hospital, a doctor is going to make a diagnosis. So basically what happens is somebody's going to look at your symptoms and going to see at what particular disease you have. If I translate that towards the world of big data, that's a classification exercise. We're looking at data points and we're trying to assign a particular class, in this case, a known disease. And we are, with a certain degree of certainty, saying, well, this patient has this disease and therefore it needs this medication. So you could even argue that a doctor in itself is nothing else than a professional classification expert. That's what they're trained to do. So if we take that one step further, if we would have histories of patient records, we could make more adequate or accurate predictions on what the disease a person will have. We can prescribe better medications. You see a lot of that. Research is currently happening to see if we can personalize medicine based upon data that we have about person's genetics. So there's a variety of different aspects. I'm going to mention one more example. Suppose that you have a broken bone, or you need to have a scan and they take a photograph. So who do you think will be able to make a better prediction of what you have? Is that the radiologist that maybe in his life has had the opportunity to say, look at 10,000 photos? But what if I could compare that photo not to just the 10,000 photos that the radiologist has ever seen, but toward, let's say, 500 million or 1 billion photographs of all the hospitals in the world? Who do you think can make a better prediction? So the value is in the numbers, and for whether it's for hospitals or healthcares, it's just going to increase the level of prediction making. So it's a very interesting question. And I hope that these kind of examples illustrate it a bit better.
Yeah, very interesting indeed. Now to Dr. Kebbe from Hamad Khan. What kind of databases can be used for big data?
Oh, it goes from your CSV files on Excel or otherwise to Oracle grade databases. Your pick and your choice. You can have MySQL bases, NoSQL bases. You can have Oracle. You could have, anything you can think about. The structure is not a problem. The brand is not a problem. The only problem is to have access to these databases, and the rest is history.
Maybe the answer also to this question depends a lot whether you are doing a solution based on big data for an enterprise, or you're trying to solve a specific independent problem. Because in the first case, you will have the opportunity or the privilege to invest in infrastructure, and it makes all the difference, or not, John?
Yeah, well, you see that cloud computing providers nowadays provide the opportunity to really analyze massive quantities of data for very limited cost. So even if you don't have the big IT backing, you don't have large IT infrastructure, signing up for a Microsoft or Google account or AWS doesn't take your pick of cloud providers. They will typically give you the opportunity to spin up big data clusters, Hadoop environments within seconds. And for relatively little money, you can run billions of records within seconds.
Okay, great. And now also to you, Jan-Willem. Hassan Sender is asking, is RPA automation part of AI?
Oh, this is, you're going to challenge me to go into a different domain of which I can also talk about for hours. You might know that I've also been heavily involved in the automation domain. So let me try to give you a concise answer to that. What RPA is trying to do is to bring...
Can you define RPA for the rest of us, please?
Yeah, of course. RPA is robotic process automation. So what that means is that we're going to execute processes as if a human being is behind the computer. That's why we're called robots. It's actually software that runs in the background. So what RPA is trying to do is look at what people do behind the computer, and then they're taking over that process. So for instance, if they're booking invoices, if they're updating records, the computer can, or the robot can learn how to do that. So what you typically see within RPA is that they are using techniques which are also incorporated in the AI domain. And Dr. Kebbe also mentioned this already. So one of the subdomains of AI is machine learning, which is very typically also used within RPA. However, take into account that the robots in RPA are not smart. So we're programming them, we're learning them what they need to do, but it will follow a process. And that's also why it's called process automation. It's not able to think for itself.
Reinforcement learning?
One more time?
Reinforcement learning?
Yeah, but also that is within a particular bandwidth. So it's never going to be able to do problem solving, or it's going to be able to come up with new ideas or anything like that. So there is a limit to that. So what you see is RPA really started as a technology just for process optimization and automation. You now see that most RPA companies are trying to embed some of these AI techniques within their product offering. So it's becoming more smart over time. But yeah, my main position remains that we're still a very long way before we can truly talk about a truly artificial or truly intelligent system.
Okay. Now to Dr. Kebbe from Isra Salama. What type of previous knowledge is needed to be a big data professional?
Okay. First of all, you need to be a little or well versed into business problems, because this is the real value. This is to cover your expenses and to realize your benefits on one hand. On the other hand, you need to have a fair knowledge in modeling, because if you have your problem inside, you need to be able to translate this model into variables and parameters. Once you have that pegged, you have to look into some mathematical skills, like what? Like in calculus, you need to know a little bit about linear algebra. In statistics, you need to have a general knowledge of statistics and going all the way to regression, hypothesis testing, stuff like that. Finally, you need to have some idea about the platforms to use, which splits into two parts. First of all, how to know your way around the cloud, and the different applications on the cloud or off the cloud, if you will. And on the other hand, you need also to learn at least one or two fourth generation programming language like Python and R that are used heavily in data science. This is not to say that if you know C++ or Java is bad. No, it's good. It's good. You can apply it. But Python is easier than R, but the graphics really suck. R's graphics are much, much better, aesthetically speaking.
So you are implying if you don't know software, big data is not for you, even the professional? Because I have a question also from Sam, our friend. What type of skills, the same almost, competency are required to get the certification, computer science, statistics, and or business consultancy? Because I believe the plan is to have 5 certifications. Right now we have 2. We have the enterprise big data professional and the enterprise big data analyst. And I believe the other 3, the scientist, the engineer, the infrastructure or architect are underway. They will be coming later on. So which of these 5 does not require the person to know a programming language? I'm a business person, I'm a project manager. What I understand from you, I'm not gonna apply to any of these, although I'm originally a computer communication engineer, but I don't do that anymore.
Well, if I can give you some guidance on that. The professional level is really looking at, can we understand big data from a business perspective? So it's looking at these capabilities that I mentioned in the presentation as well. So you don't require programming skills for the first level. For the other levels, you do. So I would say the first level is really aimed at consultants, project managers that want to know at a high level what big data is all about. They want to be able to join the conversation. They want to be able to know what other technical people are talking about. So it's a very in-depth but not technical program for the professional. The other levels, as Dr. Kebbe mentioned, is you need more knowledge and skills, because key part of being a data analyst is that you can analyze data. Key part of a data scientist is that you can build algorithms. So in the later levels, you are required to learn more about that. But from an entry or level and knowing what it is and how you can use it and what kind of skills and knowledge you need, I would say the professional is a good entry level program.
So let me take it from another perspective. It's like if you want to learn project management, or you do practice project management, have some experience, you can go to a certification from APMG or PMI or Prince 2 or whatnot. But even if I'm the project manager and I'm certified, and that would be maybe the professional, maybe I need a scheduler or a planner who is very versed in Primavera or in other applications and is extremely technical. So in this perspective, I might go and hire or utilize the analyst to do specific technical things for me. And when the analyst, from his ready-made pool of algorithms, is not capable to provide a solution for a really complex problem, a genuine problem, then I might have to call for a scientist. And then the scientist would come on and maybe tackle the problem and maybe devise a new algorithm or approach, which is not in the books of the analyst, that will help me solve the problem. And whereas the infrastructure guy is the person who will get me access to all the data, because you cannot just capture the data of the world. Some data is flowing and you have to utilize it, even if it's not physically in your database. So it sort of connects and interfaces with the various distributed data all around, so that the algorithm devised by the scientist or utilized by the analyst can provide a solution. and perhaps the engineer is the guy who cleanses the data or does the technical support work for all of these. Is my understanding correct?
Absolutely.
Okay, I'm happy. I understand now finally what big data is. Okay, and I'm a project manager, so okay, not hard for project managers. Now, Adam Abed, my friend, is asking: is this framework modular and dynamic?
Yeah, so absolutely. So it's highly modular. So it kind of builds upon top of each other. You can basically choose two different tracks. So the one that's more business analysis focused or more data science focused is the track towards analyst engineer. And then there's a more technical track, which is more towards engineering and architecture, which is more concerned with the IT aspects. So it's modular. I would say it's in depth. So it really goes beyond the level of just fundamental understanding. So you do really need to know your skills. But that's also, I think, what makes it valuable.
Okay. Now we have a long question, bear with me, from MKD, but I think it's relevant to what we're talking about. He's saying, interesting talk. I have a question or comment on the framework. We see nowadays many data professionals. However, the best description for this role does not surpass some tools or software operators providing dashboards to be used by the decision takers. I was hoping to hear that one core competency needed is a knowledge of the functionality, technicalities, and or at least a background knowledge in the trade the data represents, to be able at least to cleanse the data and know what they are providing. Data analyst professionals should not be juniors with a certification, and data analysts should be an experienced with extensive knowledge. Unfortunately, this is almost never in action at organizations. Do you agree?
That's a long question, but I think I can kind of summarize it because I think what is a very good point that it's bringing up is that there is kind of a bit of an erosion in terms of what does it mean to be a data scientist. So you see a lot of programs online or like a short course in which they say, well, you're going to get a data science certificate or you can call yourself a data scientist. Let me be very straight with you. You're never going to be a data scientist in 1 week. You're also not going to be one in 1 month. Being a data scientist really means that you have extensive and experience, multiple year knowledge on how do you get value from large data sets. You need to build your skills over time. So that's also the reason that what we've tried to do with the big data framework and the certification programs is to set a global standard and to set something that is going to be recognized from Japan all the way towards South America and every country in between. And that makes it so that the exams are challenging. And I think Dr. Kebbe is going to agree with me there. They're not easy, but it also means that it means something. We're very close to launching the Big Data Scientist examination. And also here, what we've tried to do is set a minimum level of skills that a big data scientist would need to have. So I fully agree with the question is, if you cannot cleanse data, if you cannot analyze data, if you've never done that before, you're in no way a data scientist. So be very wary on who calls itself that.
Okay, interesting. And back to the health thing, because I was trying to finish the older questions. So Sam said big data is used for COVID analysis. Is it? Is it used for COVID analysis? It is. Do you know of a case where they are using big data for COVID analysis for the pandemic? Okay. We'd love to see it or hear a case study about that later on. Now a question from also Francisco Rodriguez Blanco. What's your view about those correlations you can find through big data, like heart disease and eating a particular food, but you cannot explain? Would you take decisions based on those correlations you cannot explain? What do you think?
Let me give some insight on that. So first of all, correlation does not imply causation. So the fact that two variables correlate does not mean that there's a causal relationship between them. So you need to be careful with that. But generally speaking, if there is a strong relationship between two or more variables, I would say that the chance is more likely that there is some kind of a relationship than if there's not. So it depends what kind of decision you're making. So if you see that there's a high correlation, for instance, between two different product groups in a marketing campaign, then I would say the risk is very low. So why not try it? If the problem is which particular medicine to take, you might be a bit more careful. So it depends a bit on the use case.
And also, I believe data scientists or analysts or engineers or professionals, they are not the ultimate decision makers. They provide the right, complete data that exists to the decision makers who are physicians and who do follow their own process and have their own scheme of making decisions. But now they're not blind. They can see better and they can spot things without the data scientist to serve them, to serve their purpose. Maybe they could not have found the right answers. So a question from your student and my friend, Hamad Deek. He's the person who developed our website. Revolutions usually result to a better or more advanced outcome, just like the Industrial Revolution in Europe. So Dr. Kebbe, do you agree that the three revolutions you mentioned led us to understand more, that we are more apart from really understanding what AI is?
Okay. Well, I will tell you one thing. These revolutions have helped us reduce our ceiling. As simple as that. In the beginning, the first revolution, they were looking at placing a human mind inside a machine. And so they invested heavily in understanding the human cognition and translating that usually through Lisp programming language into the machine. That was like in the 50s. In the 90s, well, they were a bit humble and they invested in reinforcement learning, whereas they tried to put some rule-inducing software inside the machines that used to have sensors to collect data from the environment. And this data used to be analyzed and translated into a knowledge base, a rule base, basically. And then these rules, this is what's called reinforcement learning. It was like a child learning about its environment. And then finally, the third revolution, well, it was very humble, okay? And we are looking for humbler revolutions in the future, just to be realistic.
So you mean we need more time to understand what AI is?
Yes.
It's not the solution for all the problems, because I've been hearing from lots of renowned speakers, AI here and AI that, and if you don't know what AI is, why are you sitting with us on the same table? And you will not be able to run a good company, and you cannot manage a country, and so on. So, khalas. Okay. Now, okay, there are still some questions, and we are, like always, exceeded the time allowed. So let us answer them all, each one in 1 minute, please. Ali Musa. These, I want to ask if we can benefit from big data to avoid crimes. Wow. Jan-Willem.
Yeah, absolutely. So fraud detection is one of the major use cases of big data. So if you go through tax records, you can see who is, filing the fraudulent tax record. So absolutely, to combat crime, I think we're still going to see a lot of big data aspects. Also think about facial recognition software, etc. We can see a lot of that towards the future.
Yeah. And again, Isra Salama If data is reflected on 2 domains or more, will it need more than big data specialists for each domain? Dr. Kebbe.
Well, it depends on the domain itself. I mean, if there are certain overlapping between the domains, then there is no need to for redundancy in this case. It all resides on the game distributor. In this case, we are talking about the strategist, the professional. He's the one who's going to decide on that.
Yeah, if I understand it properly, I'd have one, because if there is a relationship between the 2 domains, I don't want to be instilling a silo in my architecture of solving the problem. And Ahmed Shami, how do you break down data silos, especially in large public government agencies? Jan-Willem.
So the technical term for that is to build a data lake. So it's a centralized repository in which you're combining all of your data sets. That's easier said than done. So on paper, it's easy. I know there's a lot of hesitancy and different data silos. So what you could do is try to build solutions across the different silos, or to combine them into a separate data warehouse somewhere. So there are approaches to overcome that, but it does require willingness from the individual entities to collaborate. And that's more difficult than the technical component.
This is why you defined the infrastructure or the architect, okay? Because this is exactly what they will do. And the more they are successful, they're not the analytics. They're not gonna solve the problem, but without their facilitation, even if you have a Ferrari, if you don't have the right runway, you're not gonna exceed the 200 miles per hour and still be alive.
You need the background, you need the infrastructure to be set up properly. Correct.
Yeah. And from our friend in Russia, Sergey Volchkov, what is reliability and precision of the predictions, Dr. Kebbe?
Oh, okay. It depends on
in 1 minute.
Yeah, size of the data, veracity of the data, the variety of the data, the variation of the data, so many things. But at the end of the day, there's little that you can do from the algorithm side. It's all residing within the data. That's it.
Okay. If I can add to that, these are also 2 technical terms which are being used to validify the predictive nature of a particular data set. So what that means is just in a very 20-second example, if you look at medical testing, then there's always still a result that you will get a diagnosis, or they say that you have a disease, while it's actually not the case. We call that a false positive. And the measures that are mentioning, like recall, precision, accuracy, those are measures of how well or how reliable the prediction is. And that's where this terminology is coming from.
Yeah, it's a big thing. You might have the right process, but not enough data. For example, okay. Now, from my family member that I don't know, or Adra, what are KPIs in data analysis? Key performance.
Well, here you can think about the validity, accuracy of your data sets. You can look at the time that it takes to process. You can look at the quality of your decisions. You can look at the accuracy of your prediction. So I can, within seconds, come up with more than a dozen different KPIs that you could actually measure.
Yeah. Again, back to the long question, MKD is saying, thank you for addressing my long question. My point in brief was that we cannot have one data professional for all, but a medical data professional, construction data professional, telecom data professional, and each should have previous knowledge on his topic before working on data. Thank you. Let me answer this from my humble understanding. Maybe the professional guy, he needs to understand the ins and outs and the processes of each business and the right governance and the strategy in order to be able to formulate the right questions. But after that, I believe if you have a qualified scientist or a qualified analyst with some research, even if they did not do work in medical, they did in construction, well, the algorithm is an algorithm because the data does not know it is medical or construction. What do you think of my answer? Stupid?
No, I think it's a very good reflection of the point. I think the main point is that no matter what you need domain knowledge. So a doctor that looks at, I'm not a doctor, if I look at a medical photograph, it means nothing to me. But somebody who's trained to look at that will immediately know what's going on. So you will, besides knowledge about algorithms, you will always need domain knowledge.
There's an answer from Nuf Sharif. Yes, actually, we do use data analysis and COVID-19 data-driven decisions. Maybe we can discuss this later on to share your experience. Okay, I think we covered most of the questions, and by that, if you have any final comment from Dr. Kebbe, from Jan-Willem, I would like just to point out one thing, that advisors within its partners and ecosystem, we do provide services, consulting services. And now we are going to go into the realm of big data because we have with us Jan-Willem and the group that he represents. Whereas with respect to offering accredited training, maybe we did not mention that now Advisors is an authorized training organization for APMG. And of course, Dr. Kebbe is our accredited trainer for enterprise big data professional. And soon he will also have other certifications that he can offer in this realm. We mainly focus on business to business, but I told my team, since we have people on our ecosystem from over 50 or 80 countries, I don't know how much, if there are lots of people who require one of these certifications, we'll be happy to offer a virtual course. It's not our strategy to announce a course and ask people to register, but from our ecosystem, and Mustafa can follow on that. If we have enough numbers, we'll be more than happy to offer a public course. Other than that, we always offer to companies and organizations. So having said that, again, I'm very, very happy in this session. I believe myself, I learned a lot from both of you. And if you have a final word, Dr. Kebbe?
Well, it's a growing field in understanding. The techniques have been there for a long time. And I think that John Tukey said it well in 1962. By that time, when he talked about data analysis as opposed to the theoretical statistics, he just blew a bomb, big bomb. Everybody was, oh my God, what happens? What's happening? We are still finding the repercussions of that word till nowadays, and it is going to continue in the future. The main thing is that to take away the myths and instill realistic frameworks. That's it.
Jan-Willem, before you go to sleep, thank you very much for staying that much late. Okay, and tomorrow morning when you wake a little bit late, please don't blame us. We are very happy to have known you and have you with us. Okay, one final thing.
Absolutely. Well, I hope that this was a very good discussion. I had a lot of fun looking at all of the different presentations. I also learned a lot from our discussions. I think it was very, very useful. So I wanted to end with thanking you for the invitation. It was really a great pleasure to co-host this session with you.
Thank you very much, and looking forward to future participations together. This is only our kickoff with respect to big data, a new, very interesting field, lots of things to learn in the future. And until we meet again on September 24 and 25 with the PMO virtual summit, stay safe and hope to see you always with us. Thank you and have a very good night.
Thank you so much.
Thank you. Welcome to Advisors. My name is Dr. Saadi Adra, founder and CEO. We take joy in networking our partners with the thought leaders of our domain. We feel pride in enhancing our partners' lives through strategy, consulting, and education. We do this with integrity and professionalism, yesterday, today, and tomorrow. We believe in crafting and sharing authentic knowledge that makes our organizations better. We define our success when we can help your organization reach a point whereby you don't need us anymore. This is why we provide a myriad of services focusing on training and capacity building, the career development programs such as the project engineer, postgraduate diploma, and various professional consulting services.
Express my support for advisors. We love my advisors.
I am forever grateful to the advisors for the support they have given, the guidance, and for helping us and many others across the world to get solutions in areas where we felt we had stagnated and gotten stuck. I sincerely want to thank the advisors and encourage them to continue with this very good gesture and this cause, because many people out there are still hungry for knowledge and we seek to learn from each other.
It is a great pleasure to benefit from advisors' webinars.
And I want to thank advisors for sharing valuable knowledge to benefit all.
I'm proud of advisors. Thank you.
I support advisors and I benefit a lot from their weekly webinar sessions. Thank you.
I'm proud of advisors for helping us thrive and grow even stronger in the face of adversity everyone is living nowadays. Behind every webinar, there are a great deal of skilled professionals helping us keeping our mind and experiences updated, which ensures we are always performing at the best ability. Thank you, advisors.
For attending valuable webinars. I love advisors. Nandri.
I love advisors. Thank you.
I thank advisors and I appreciate the work they do. Big up.
And I benefit from advisor webinars. Thank you very much.
I support advisors.
And I support advisors.
Yeah, I thank and I'm proud of advisors.
Hi, I enjoy advisors webinars.
And I support advisors. Keep up the good work.
High level of speakers, but above all, the passion of Dr. Saadi Adra to get the most answer to the questions of the audience. Thank you, advisor.
Recommend stay tuned with advisors. Thank you.
This is to express my gratitude to all advisors and support them to keep working on.
I love and I'm proud of the advisors.
In the Kingdom of Saudi Arabia, and I support advisors.
I support advisors.
I attend the weekly advisors webinars and social.
I support advisors.
And I support advisors.
And I thank and am proud of advisors. Thank you for all lectures.
I support advisors.
I support advisors. Thank you.
I love and keen on advisors. Thank you.
Hi advisors team, thank you for knowledge sharing. I do really appreciate it.
I personally thank Dr. Saadi Adra and advisors team for arranging these webinars during this difficult time.
I really appreciate all the topics that advisors are offering in their webinars.
I benefit from advisors' webinars.
I support advisors in all webinars.
I support advisors.
Thank and I'm proud of advisors.
I benefit from advisors' webinars.
Benefit a lot from advisors' webinars.
I support advisors from Chile.
My full support for advisors for what they are doing. Keep it up.
I benefit from advisors' webinars.
I've really benefited from the webinars. Thank you for organizing those webinars. I'm proud of you guys. Thank you. Keep it up.
I support and recommend advisors to everyone.
I thank and proud of advisors.
I would like to appreciate the value or benefit that I've been getting from the advisors group through their webinars and interactions. I think they're doing quite a good job in pushing forward the project management domain, and I would commend that they continue doing this good work because it is very beneficial. So that
over the years, Advisors has shown its relentless and extreme commitment towards the further enhancement and development of both theoretical and practical knowledge in the field of project management, engineering, and fast-paced technology. I couldn't be more proud as I am today to endorse and express my support for Advisors. We love Advisors. Thank you. Cheers.